Hi there and welcome to today's class. Let's proceed in the study of differential equation. Let's dive into the second method called the variable separation method. Last class we dealt about the first method called the direct integration method. For this class we'll look at the next method. If you haven't watched the introduction to the first method, I'll leave the link to the introduction to the first method in the video description. So check the video description. You see a link that will take you to the full tutorial video for the first method called the direct integration method. Let's proceed with the second method called the variable separation method. Please note this. Some differential equation involves a mixture of two variables. For such problem, the variable must first be separated by collecting like terms with their integral variable. Now, here is the thing to note. Here is one key concept to note. When it comes to differential equation for the introduction class, we said about like five to four methods last class when we did introduction to the differential equation. The first method there was direct integration method. The idea behind that one is that we said for direct integration method, the idea there is that you are having the y over the x to be equal to something in terms of x only, right? So for the first method, you are having the y over the x is equal to something in terms of x. That is for direct integration. Now we're on the second method. How do you identify? How do you spot out if you are in exam hall and are given a differential equation question? How do you know that this method though is not a direct integration method? How do you know it's a variable separable? It's simple. For variable separation method, the idea is that there is a mixture of x and y in the equation. So it means that you'll be having the y over the x is equal to something not just in x, but what they'll mix both x and y for you in the equation. That is spot out variable separable. So in example, if you're having the y over the x equal to something in terms of both x and y, it could be variable separable. It could be variable separable, right? So then you spot out variable separation method. Before we proceed, I'll give you one bulletin to note. So with this bulletin, any question you see, apply this bulletin and then you'll be able to solve any problem under variable separation method. Please note, move all the terms that have y as well as the y and place them on the left hand side. Also, move all the x terms together with the x and place them on the right hand side of the equation. Please, what I just gave you now is a bulletin. Any question under variable separable, your first task is to move y and the y to the what there to the left hand side of the equation. Also move the term having x and also the x to the what there to the right hand side of the equation. This is how you solve problem when it comes to variable separable. I said for variable separable, you spot out variable separable. How? Ensure that there is a mixture of what there both x and y in the equation. Yes. Some cases whereby you have mixture of x and y in the equation and still yet variable separation method will not work. Then you move to what there? Move to substituting y as equal to what there? Bx. That's the other method there. We'll look at that method next class. But I've explained how you can possibly spot out variable separable. When you have d over the x and a mixture of what? X and y. then your first that comes to mind is what? Using variable separation method. For variable separation method, how do you solve problem under it? Your first task is to move y, and the term is to move y and the y to the what there? To the left hand side of the equation. Move the x term and the x to the what there? Right hand side of the equation. This is simply the basic concept for variable separation method. I'll list out all the example we'll be going through in the study of variable separation method. So we'll be looking at several examples. Number one, dy over the x is equal to exponential x dot exponential y. Exponential y. Second example, dy over dx or the y dx is equal to y over x. Number three, dy over dx or the y dx is equal to x squared over y. Number four, we're looking at number 4, dy dx is equal to y ln y all over x. All right, number 4. Number 5, we'll solve dy dx is equal to 1 plus y squared all over 1 plus x squared. Number 6, dy dx is equal to y tan x. Number 7, we have dy dx is equal to x exponential y minus x squared. Finally, we look at final example. We look at 1 plus x squared dy minus xy dx is equal to 0. All right. For variable separation method, these are the example I think we should solve that will increase the in-depth understanding of variable separation method. So let's go through solving these problems one after the other. For today's class, we'll focus more on example 1. In our next video, we'll do example 2 and 3, and then we'll solve all of them as we proceed. Let's start number 1. Then let's solve number 1. So let's take number 1. Let's solve number 1. All right. Let's solve problem 1. Let's solve problem 1. All right, we are having the over the x is equal to exponential x dot exponential y. Now, here is the idea. Ask yourself, is this one a direct expression method? Of course, no, it is not a direct expression method. Why? Because I'm having a what? A mixture of both x and y in this place here. So it could be what there? Variable separable. Yes. So this man here is a variable separable. Why? I have a mixture of what? Both x and y. Now in this case here, what do you do? Say your first task is to move the y and the term having the y to the what there? To the left hand side. Next up, move the term having x and the x to the what there? To the right hand side. That's all. So first, my task is to perhaps if I want to, it's possible. I want to this exponential y. I want to bring exponential y to the y. So I want them to y and y should be together, x and x should be together. So it's easy as I can take this man this way and still be correct. So I'm saying that you have the y, this gives you the y over, bring this man down here, exponential y equals, I have exponential x. Replace this one here, that gives you with the x. As simple as that, please. So it's easy. Just put this one here, take this one back here. That's all. Right? So this is what I have here. Or perhaps want to save time, or perhaps for better understanding, if I'm having the y over the x is equal to exponential x exponential y. What I did there was just that here was a visible one, and I use what? Cross multiply concept. So this times this, so this one times this gives you, okay, the y times y gives you the y is equal to everything here times there gives you exponential x exponential y and what there and the x. So I want to bring the y here. I want to bring term having y here. So I can say exponential y. So divide both sides by exponential y. Divide here by exponential y. Divided by exponential y. This will cancel this. So I'm having divided by the x and exponential y. This one here. Same thing. Exponential x dx. Exponential x dx. This I go through it. So at your level by now, at your level in your studying career of mathematics, you should be able to do this way instead of going through this process. All right, my next task here now is to integrate through. All right, integrating through, that gives you the integral of the y over exponential y is equal to the integral of exponential x, of course, dx. All right, I have this one here. My next task now is to shift out the y. That is, I'll have the integral of 1 over exponential y dy. Of course, 1 times dy gives you dy over exponential y. So this and this, I say the same thing, is equal to the integral of exponential x, of course, dx. All right. Now here's the idea and technique, please. For the left hand side, I'm differentiating this with respect to the y. I'm differentiating this with respect to the x. That's the idea. So here's the idea, please. Look up, please. Look up. Let me explain something, please. If I integrate exponential, perhaps let's say 2x, for instance. How do you integrate this? If I want to integrate exponential x squared, what do you do? Now listen, let me show you the technique that is there. We said it's easy as, for integration exponential function, it's easy as differentiate the power. I have 2x. If I differentiate 2x, I'll have what? I'll have 2. If I differentiate 2x, I'll have 2. Put the 2 as denominator. Now repeat the question. That's exponential 2x as numerator. That's all. The shortcut to it, that's all. This is how you differentiate, this is how you integrate exponential function. Right? So here's the idea, please. Now here's the idea, please. Here's the idea. If I integrate this one here, what do you think you have here? First is first, I'll take this one back to indices. That gives you the integral of exponential minus y dy is equal to the integral of exponential x, of course, dx. From here, I will apply the idea I used here, right? So we said your first task to integrate exponential function. Your first task, differentiate the power. If I differentiate minus y, that gives you minus 1 as denominator. Then repeat the question, exponential minus y as numerator. Some people will ask me, how do you know that if you differentiate minus y, how do you get minus 1? It's more like saying differentiate x for me. What's my answer? If I differentiate x, I'll have 1 as my answer. Right? If I have y is equal to x, it means that the y over the x is equal to differentiate x. That gives you what? Just 1. Similarly, if I differentiate only y, that gives you 1. But this negative sign comes down here. Alright, please go and learn integration. Is equal to, we know very well that if I integrate exponential x, I will still have backward exponential x. Why is this so? Because differentiate x, I will have 1. Repeat the question, exponential x. Anything over 1 gives you that thing. Alright, then I have plus c, the constant of integration. From here, I want to try to make sure that, because the idea is that they're trying to make y to be equal to something, because the task is to make y subject, right? So from here, what do you do there? We know that this negative comes up here. That gives you negative exponential minus y all over 1 is equal to exponential x plus c. All right, we're here. We are here, please. Let's proceed, please. My next task, obviously, from here would be, anything over 1 gives you that thing. So we're having negative exponential minus y is equal to exponential x, of course, plus c. All right. So my task here is to make sure, I want to make y to be the subject of formula. So what do you think we'll do here? It's easy as, my first things first is that I want to bring this y in front of this. So I'll apply the idea of taking log or taking ln. So I'll take the ln of both sides, take ln of both sides. So that gives you ln of minus exponential minus y is equal to ln of exponential x of course plus c. All right, I have this one here, exponential x plus c. So I'll take the ln of both sides this way. So from logarithm or from ln idea, we said both log and ln are similar to each other, right? So this minus y can come to the front here. If I have log a to pass b, from logarithm, the idea is that this b can come forward here. That gives you b log a. These are still the same thing. So this minus y comes to the front, gives you minus y, of course, ln negative exponential, right? Exponential is equal to, I have ln exponential x plus c. All right. So I want to make sure that y is the subject formula here, because for y, we're trying to take this stuff here back to y. So we're here. My next task now is to listen, please. The idea here is that I want to make sure this y stands alone. Now here is the relationship between ln and logarithm. Please listen. If I have ln means log of something to base e. Ln of something is equal to log of something to base e. Now here's the idea, please. Here's the idea, please. Listen to this idea, please. Here is taking to note, please. From logarithm, we know that if I have log a base a, this man is 1. True or false? True. If I have log a with that same base, they are the same. That gives you 1. So it means that this gives you minus y. We said ln means what? Log e. That's log to base e, right? Then I have minus e here. That gives you minus e this way is equal to ln exponential x plus c. Now observe this technique, please. Log a to base a gives you 1. So log e to base e gives you 1. But I have negative, that gives you what? It left what? Minus 1. Not just 1. Listen, log A base A is 1. So log E base E, they are the same thing. That should be 1. But mind you, there's a negative sign here. That will be minus 1. All right. That gives you minus 1 into log of base E to base, log of E to base E is 1. But minus is 0. That gives you a minus 1 is equal to, I have ln exponential x plus c. From here, minus minus gives you plus. Y times y gives you, so I can say that y now is equal to ln exponential x plus c. This is the required solution for the differential equation. This is a solved problem of this kind. Let's proceed in the second and third example of this method called variable separation method. That is solve problem under variable separation method. As you can see, please. One, learn integration, please. I differentiated here with respect to, sorry, here is y, please, the y, please, the y. I differentiated this part here with respect to the y. I differentiated this part here with respect to the x. This is a process you should always look out for, right? Always watch out for this process. It's always constant. You always differentiate something with respect to the y and with respect to the x. So this is a procedure you should look forward to, right? You always differentiate something with respect to the y and also with respect to what? The x. So I have these stuffs here. This is a solve problem of this kind. Let's proceed in the second example of this variable separation method.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It's of course 1,000 naira, or you go for the other level student to have access to both. Right, so once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, WAEC/JAM student, WAEC/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.